All right, let's dive right in. Today, we're going to unpack one of the most incredible stories you'll ever hear. Our own, the story of human survival. And it's a tale that's not just written in dusty old history books, but deep inside every single one of us, in our DNA.
I mean, just look at us now. There are over 8 billion humans on planet Earth. 8 billion! We've built sprawling cities, we've walked on the moon, we've connected the entire globe. You'd think, looking at all this, that our success was, inevitable. A straight shot from the Stone Age to the Space Age.
But what if I told you that this massive, planet-spanning success story is hanging by the thinnest of threads, that hidden deep in our past, there are these moments where our entire species was pushed right to the very edge of oblivion.
Okay, I want you to burn this number into your brain. 1,280. It doesn't look like much, does it? But this tiny number, this is the key to understanding just how ridiculously fragile our existence has been. It represents one of the single greatest mysteries in our history, and today, we are going to solve it. But first, let's get a little perspective. Meet Homo erectus. These ancient relatives of ours were a huge success story. I mean, they were around for over 1.5 million years. That is so much longer than we Homo sapiens have been on the scene. They were pioneers, the first to walk like us, the first to leave Africa. And yet, despite all that success, they're gone. Their story is this powerful reminder that survival is never, ever guaranteed. So, how in the world do we know what happened to our ancestors hundreds of thousands of years ago? Well, the clues aren't just in fossils buried in the ground. Nope, they are encoded inside every one of us. So we're going to use this incredible tool from genetics to act as our detective and peer into the past. And that tool is called effective population size, or NE for short. Now, this is not a simple head count of every person alive at the time. Don't think of it that way. Instead, think of it as a measure of our genetic variety. A big, diverse gene pool tells you there was a large, healthy population of ancestors passing on their traits. But a small, limited gene pool, that tells us the number of ancestors who are actually having kids and passing on their genes was dangerously small.
So the actual number of people alive today, what we'd call the census size, that's just a snapshot of right now. But the effective population size, that's the real story. It's like a long exposure photograph of our past, a genetic echo that reflects the history of our breeding population. And it's almost always a much, much smaller number.
So why does the past have such an iron grip on this number? It's because of a quirky bit of math. A single really bad population crash, what we call a bottleneck, has this huge outsized effect on the long-term genetic average. It's kind of like your commute. You might have 9 days of easy 10-minute drives, but if on that 10th day you get stuck in a 5-hour traffic jam, well, your average commute time is totally shot. That one horrible day dominates the average. And it's the same in our DNA. A single bottleneck leaves this massive genetic shadow that lasts for thousands of generations.
Okay, we've got our genetic detective tool ready. So let's open our first case file. And this is where that mysterious number, 1,280, finally comes into play. For a long, long time, scientists have been scratching their heads about this weird gap in the fossil record. Around 930,000 years ago, the trail of our ancestors in Africa and Eurasia, it just goes cold. For over 100,000 years, it's this period of eerie silence. It's like the story just stops. So what on earth was going on?
Well, this is what our DNA is now telling us. A recent study used this genetic tool on thousands of modern people, and their findings were just stunning. They found evidence of a catastrophic population crash right smack in the middle of that fossil gap. Our ancestral population was slashed down to just 1,280 breeding individuals. That's it, a group small enough to fit inside a high school auditorium. We lost nearly 99% of our breeding population.
And this wasn't just a quick dip, oh no. The researchers concluded that this near-extinction event lasted for about 117,000 years. For over 100 millennia, the entire fate of humanity rested on the shoulders of this tiny, fragile group. It's the longest, most severe bottleneck we have ever found. It really hammers home that a huge part of our survival story is just sheer luck. So surviving that bottleneck was one thing, a marathon of pure endurance. But our story is also about facing sudden, violent shocks to the system. In our next case file, it involves one of the most violent events in recent geological history, the Toba supereruption. And oh, it comes with a fantastic twist.
So, around 74,000 years ago, the Toba volcano exploded. We're talking the biggest eruption in the last 2 million years. The old theory was that this created a volcanic winter, plunging the entire globe into a deep freeze and causing yet another human population crash. But guess what? New evidence is completely flipping that story on its head. Instead of a simple tale of global disaster, we're finding a much more interesting story of human ingenuity.
At a site in Ethiopia, researchers found out how our ancestors actually responded. The Toba eruption didn't cause a deep freeze there. Instead, it made the local climate drier. Rivers, which were like these blue highways across the landscape, started to shrink, concentrating water and food into these little pools. And humans adapted brilliantly. They switched their diet to fish, which were now super easy to catch. And get this is right where we see the oldest evidence of archery, a major technological leap. They didn't just survive a crisis, they innovated their way through it.
Okay, so we've seen our ancestors adapt to these massive environmental challenges. But our final case file reveals that some of the greatest pressures on our species didn't come from volcanoes or climate change. Nope, they came from us. It was a social revolution that completely reshaped our genes.
So geneticists looking at our DNA noticed another really strange event. Around 5,000 years ago, during the Neolithic period, the diversity of the Y chromosome, which gets passed down from father to son, just plummeted. For the longest time, the leading theory was pretty grim: constant, brutal warfare between different groups, with entire male family lines being wiped out in battle. But a lot like the Toba story, new research offers a surprisingly different explanation. Turns out, this genetic bottleneck probably wasn't caused by widespread war at all, but by a quiet, fundamental shift in how human societies were organized.
So what was this revolutionary change? It was the rise of patrilineal societies. That's where your identity and your inheritance are passed down through your father's line. This new system created big differences in status between male family lines. And over generations, the families of high-status men just expanded dramatically, while other male lines just fizzled out and vanished. And just like that, you get a massive drop in Y chromosome diversity, all without a single battle, a social revolution with a huge genetic impact.
So, after digging through these 3 incredible case files, from near extinction to a supervolcano to a social revolution, what's the final verdict? How did we, against all these odds, manage to survive and become a global species of 8 billion?
Well, it turns out there's no single magic bullet. Our survival is this complex recipe. It required a huge dose of sheer blind luck to squeak through that first great bottleneck. But it also depended on our incredible adaptability, our ability to turn a crisis into an opportunity. It was driven by our capacity for social evolution, for completely changing the rules of how we live together. And, of course, it was powered by our amazing technological ingenuity, from the first stone flakes all the way to the bow and arrow.
You know, the story of our past is such a powerful lesson for our present. Our ancestors faced existential threats from the environment and from their own social structures, and they survived by adapting. And that leaves all of us with a pretty critical question to think about. As we face our own unique set of global challenges, from climate change to social transformation, which parts of that ancient survival recipe, luck, adaptability, social change, or technology, are we going to need most to write the next chapter of the human story?